Welcome to this Sketching Divergent Boundaries video lecture. In this lecture, we will examine the relative motions between divergent plates, including any distinctive features that result from these motions. The main objective of this video is to teach you how to sketch side views of each of these divergent boundaries, so be sure to have your paper and pen handy. Generally speaking, a divergent boundary is any boundary at which two plates diverge, meaning they move away from one another, like so. The first instance that we'll consider is continental-continental divergence, in which a single continent tears itself in two. We can see that this divergence results in thinning of the continent. The topography of the thinning is kind of stepped, and the name of this feature is Rift Valley, because it creates a giant rift in those continents. The underside of the plates, as you can see, is a bit more muted than the top, but again, they do have a top and a bottom. Crucial, important that you have both. It is possible to get some volcanoes at this boundary. Although we won't be concerning ourselves with that type of volcanism too much in this class. Here it is in 3D along with that volcanism that I just mentioned. Let's see, just as a side note, that volcanism created there, we'll learn the mechanism for why that happens next week, but because the lavas and the volcanoes that result are some of the strangest in the world, unfortunately we just don't really have the time in this class to get into them very deeply. If you're interested in that, be sure to check out volcanology when we offer it in another year. Moving on to the case of two oceanic plates diverging, we have what physically is happening here is that this feature, the topographic high, is called a mid-ocean ridge. So MOR stands for mid-ocean ridge. Which is an underwater volcanic mountain chain. The most active volcanism on the planet actually happens at the mid-ocean ridges. Okay, this is where new basaltic magma, low silica magma erupts and cools, adding on to the volume of these oceanic plates. Here it is in 3D. Again, we'll get into the magma generation aspect next week. We'll talk more about the type of rock, basalt, and what silica has to do with all of that next week. But from here, you should definitely be able to envision the ridge, right? That's here, and its associated volcanism. In fact, in map view, you can again depict the volcanism with a series of triangles to represent volcanoes, and label it the mid-ocean ridge. You might be thinking that the next divergent boundary to consider is Oceanic-Continental. However, it isn't. This type of boundary could only form at an existing transition between oceanic and continental crust, which represents an incredibly small portion of the Earth. And it turns out that we just don't see this boundary type when we look out into nature. The good news is that means you have one less thing to worry about. What I want you to think about next is what would happen if this continental rifting here just continues indefinitely. Can you imagine it? Letting the two sides of these continents pull and pull and pull away from one another? The end stage of continental rifting thins that continental crust so much that eventually the continent splits into two. At that point, magma from below comes to fill the gap and creates a brand new mid-ocean ridge, right? A new oceanic lithosphere is formed between those pre-existing continental plates, okay? This is actually why the coasts of South America and Africa look like they fit together like a puzzle. It's because long ago they rifted apart from one another, opening up the Atlantic. And this plate boundary here is actually a mid-ocean ridge in the middle of the Atlantic where active volcanism is currently occurring. And it is in some ways pushing these two plates farther and farther apart. So South America actually gets farther from Africa by just a few centimeters every single year. So we just have the two types of divergent boundaries shown again here. The lower image is curved a little bit. That's just to emphasize that the planet Earth is actually curved. Don't let that trick you into thinking there's any sort of major difference between the top image here and the bottom image. This concludes the Sketching Divergent Boundaries video lecture. At this time, you should pull out a fresh piece of paper, turn off the video, and see if you can sketch these boundaries from memory. Good luck!